I'm sure that most of you have watched Star Wars. Well, when I was about 10 years old, I was totally excited when the Millennium Falcon or any spaceship jumped at hyperspeed. And whenever these spaceships passed by in space, they would make a type of swoosh sound, which kind of made me curious. As time passed, I always wondered if we could actually hear that swoosh of these spaceships for real. Obviously, no. They are merely sound effects that the film producers give to make a dramatical impact to the movie. But in reality, can we actually hear sound in space? When we observe through a telescope, or even without, these stars in the form of light are refracted, and we can observe or see these dramatic events as they unfold throughout the universe. We can say that the universe is a kind of silent film, and the observers are like a cameraman who capture and collect data, which helps us to understand the universe better. But what if I told you that the universe is not a silent picture? Would you believe me? I'm sure that some might agree or disagree, but I would like to convince you that the universe can be heard right from the Big Bang till date, and the sound is played in space itself. To understand this better, let us analyze the basics of sound here on Earth. Sound travels through a medium as waves. An example is when we speak, the vibration of the vocal cords compresses the air, and air as a medium carries the sound waves to the listener, whose brain interprets the activity as sound. Okay, so space must need a medium so that we can hear sound. But we know that space doesn't have any medium. Instead, space creates ripples in the fabric of space and time through dramatic events which bang like a drum. A perfect example is when a star dies, it eventually releases a lot of energy and forms a black hole. Black holes don't release energy in light and can be seen indirectly. They destroy stars, wreak havoc on planets, vacuum trees. Even light cannot escape its grasp. So, if you're in a spaceship and detect a black hole a few light years away, I suggest to turn to the opposite direction, otherwise, you'll be stretched like a spaghetti. Yeah. Black holes can create ripples in space that spread out like ripples in the pond, which make an enormous dent in space-time. These are commonly known as gravitational waves. Gravitational waves are waves which stretch and shrink space. Even if you and I started to dance around, like in this picture, we would even cause gravitational waves. But these would be extremely small, practically undetectable. Thanks to Einstein's general theory of relativity, it tells us that space and time are elastic in nature. If space was an elastic fabric, and if there were an object with a massive mass, then space would be bent or curved. Since black holes have a massive density, they curve and distort space-time, resulting in the formation of gravitational waves. As gravity is one of the weakest of all forces of nature, so you will need an astrophysical object massive enough to make these big ripples to detect. So, to understand all of this, let us go back in time. In the distant reaches of the universe, two black holes, each about 30 times as massive as our own sun, were locked into orbit and spiraling towards each other. The only thing that you can see could be seen was the gravitational field distorting the light of distant stars. The closer it got together, the more gravitational waves were. Within a fraction of a second, they collided with each other and formed a single massive black hole, nearly one half of the speed of light, converting the combined black hole's mass to energy. This energy is released as a final strong burst of gravitational wave, lasting only a fraction of a second, which expanded through the universe, passing unimpeded through countless of galaxies. About 1.3 billion years later, it reached Earth. These waves alternately stretched and squeezed space. As you can see happening here for the Earth, but of course, this is highly exaggerated so that you can see its effects. Mathematically, if you could find the amount of squeezing and stretching, it would be so tiny a mere fraction of an atomic diameter. So we need a complex detector to detect these gravitational waves. And LIGO was the one who firstly detected and observed these gravitational waves on 14 September 2015. LIGO, the Laser Interferometer Gravitational Wave Observatory, used two detectors, one in Hanford and other in Livingston. These detectors use an instrument called the interferometer, and they fire laser beams along two 4-kilometer long evacuated tunnels, and the light recombines it to create an ironic pattern known as the interference pattern. The only thing that you need to know is when the gravitational waves pass through the interferometer, it will squeeze and stretch the arms of the detector and would have a measurable impact on the interference pattern, causing it to shift. And that's that kind of shift that the LIGO team detected was, in fact, gravitational waves and converted them into sound. They detected gravitational waves from the two collided black holes, and this is how it sounded. LIGO team have detected a lot of gravitational waves since then, but these are so small that our ears couldn't detect it. This can help us to understand our universe better because 95% of the universe is still invisible. With the help of gravitational waves, we can assemble a detailed map of the universe called the stochastic gravitational wave background. Apart from the cosmic wave microwave background, gravitational wave background can contain a crucial info about the universe's very first moments and its mysterious era of inflation, but they are pretty hard to detect. In 2034, scientists will be launching a spacecraft to detect these gravitational waves called LISA, the Laser Interferometer Space Antenna, where we might be able to understand more about the expansion of the universe, which is actually pretty cool. I'm not sure what we'll find or discover in the near future, but I can definitely say that the future is very optimistic. I'm positive that there are things out there which we may never be able to see and only be discovered by listening. For millennia, we have explored the universe using light. With all of these discoveries, it will make a new era in which we'll explore the unknowns of the universe using sound and even coming closer to listening to the Big Bang. The possibilities are endless. Thank you.